in 4.1, or just in chapter 4, we're solving systems of linear equations. Basically, it's two lines that are coming together. All right, we're going to have two lines that come together. In this whole chapter, chapter 4, I'm going to be showing you several different ways to solve these. You choose your method, whatever way you want to do it. What you're looking for is this point right here, where they intercept. Where do the two lines intercept? All right, well, sometimes they're not going to intercept. Sometimes they're going to be parallel. And sometimes they're even going to be the same line. So we got to look at those situations. All right, so again, our concept is in chapter 4, where do the two lines intercept? All right, so I'm going to show you at least 3 methods on how to do this. So you choose the method you like the most and stick with it. Doesn't matter really what the book tells you to do or the homework tells you to do. You choose the method that you feel the most comfortable with and just do it the whole time if you'd like. All right. So chapter 4.1 is deciding whether an ordered pair is a solution. So sometimes they're going to give you an ordered pair, and they're going to give you 2 linear equations. Again, these are just 2 lines that are going to intercept probably at some point, unless they're parallel or the same line. We need to determine whether this ordered pair is where they meet. All right? And so in order to do that, it's very simple. You're just going to take your point, which is x is 4, and your y that's 12, and you're going to do the first equation, 4x minus y equals 12. But in place of x, you're going to plug in a 4. So it's going to be 4 times, instead of x, it's going to be 4 times 4, minus, and instead of y, we're going to put a 12 equals 2. Then just do the math. Make sure you follow order of operations always. 4 times 4 is 16 minus 12 equals 2. Does 16 minus 12 equal 2? No, it equals 4. 4 equals 2. That does not work. Therefore, this is no solution. All right, this does not work. The answer to this is no, because this didn't work. I don't even need to worry about the second equation. But if this had worked, then I need to go to the second equation. But since the first one didn't work, there's no need in doing the second equation. So now, practice 2 says the same question. I just didn't write the whole question. Determine whether this point is a solution to the system. So we're going to do the same thing. Take my first equation, x minus 3y equals negative 7, but in place of x, I'm going to plug in a negative 4 minus 3y, but instead of y, I'm going to plug in a 1 equals negative 7. Again, make sure you always follow order of operations, so I have to do my multiplication first here. So we have negative 4 minus, what's 3 times 1? 3. 3 equals negative 7. Negative 4 minus 3 equals negative 7. Is that true? Yes, that one works. This works, so therefore I have to go to the second equation. 2x plus 9y equals 1. But again, instead of x, I'm going to plug in a negative 4. So it's 2 times negative 4 plus 9 times y being 1 this time, equals 1. So again, follow order of operations. We have 2 multiplications. So we have negative 8 plus 9 equals 1. Then do that math. 1 equals 1. Is that true? Yes. So the answer to this is yes. This one is no. It did not work because 4 does not equal 2, and these both came out to equal in each other. Therefore, this is a yes. This solution will work. This is where they intercept the line. These 2 lines intercept at negative 4, 1.